In this talk, I will provide few tips for designers to create designs for Android devices, which scales well on almost all Android phones and are still developer friendly. So, what's the challenge in this process? Basically, as all of us know, that Android is very diverse OS. There are lots of device manufacturers, tons of device models, various screen sizes, and all that. It's very difficult to create designs for all these devices.
Sorry, start asking questions for very good. So, do you think with this Android one that is now in the market, so Android has kind of tried to standardize things, rather different manufacturers, different designs. I mean, I'm seeing it like a bit standardized now with Android one.
So Google is restricting few things, but it's still open for all the manufacturers. There are very few constraints that Google has imposed, but the manufacturers can develop devices of any screen sizes, any densities. There is no such restrictions. So this diversity is beneficial for end users as they can choose any device which suits their needs, but it's challenging for us, for developers and designers, to create designs and developing those applications which looks pretty well on all these ranges of devices. Let's see how diverse the OS is. Basically, there are more than 1,000 device manufacturers who manufacture devices for Android. There are more than 18,000 distinct devices available in the market.
18,000.
18,000. It's a huge number.
Okay.
The screen sizes of Android phones vary from 2.6 inch up to 6.3 inch.
Can you go back? 0 to 10 inch. Okay.
No, it's 2.6 inch to.
Okay, I saw the bottom 0, so I thought how can it be?
The screen resolution of Android devices vary from 240 to 320 pixels up to 1440 to 2560 pixels.
It's LDPI, MDPI, right?
So it's the density.
It's the density.
With density of 120 dpi to 534 dpi. So we will discuss the density buckets further. So as you can see, there are lots of Android devices, lots of variation. Android provides the basic structure to deal with this diversity. Let's see what Android provides us to deal with this. So Android puts all these devices into 6 density buckets. These are LDPI, MDPI, SDPI, XSDPI, and so on. Basically, MDPI is the base density for Android. Devices with around 160 dot per inches lies in this category. LDPI is lesser density device. SDPI is around 1.5 times of base density devices. Similarly, XSDPI, double XSDPI, and triple XSDPI. So, what's the benefit of categorizing devices in this way? By categorizing devices in this way, Android wants us developers and designers to treat devices sizes in density independent pixels, not in actual resolution or the device density. What is density independent pixel? Density independent pixels is we can calculate the density independent size of any device by dividing its actual resolution by density conversion factor. So what's the density conversion factors? Density conversion factors are based on the density buckets. So here are the density conversion factors of these density buckets. For MDPI it's 1. So if we have an MDPI device, its density independent pixel size will be exactly same as its actual size. For other density buckets, the conversion factors are like this. For LDPI it's 0.75, for SDPI it's 1.5. and so on.
First, how many number of pixels are there? I mean, one density can accommodate how many number of pixels, right? If you do a literal interpretation of this.
So basically, if we are seeing a high density device,
Right.
in that case, its screen size won't go beyond a certain range, but there are lots of pixels at that screen. So for accumulating our designs on those devices, we don't need to put that much information on that screen. We just need to provide high density assets for to accumulate that density. So this is the point of categorizing the devices into these density buckets. So suppose we have an LTPI device of 240 to 320 pixels. If we calculate its density independent size, it will be 320 to 426 dB. As we can see, as it's an LTPI device, we have divided its actual size with 0.75, its density bucket conversion factor. And we have, suppose we have a double access DPI device of 1080 to 1920 pixels, S4 as in this category. It will be of 316 to 640 dB. So now we can see devices are ranging in a certain size, in a certain size, certain variations of size. It's not that vast. It's now lying somewhere in 320 dp width and 360 dp width and 426 height and 640 dp height instead of 240 to 320 up to 1440 to 2560. So with this approach, what we achieved. In this approach, designer can design applications for one density bucket and can provide assets for rest of the densities, for all of the densities to the developer. Developer can put those assets in right drawable folders which Android provides us. And on runtime, Android will pick the right asset based on the density of the device. So if we want to show this icon in our application, designer can provide us the icons of all the density buckets. We can put them in right folders, and Android will pick the right asset at the runtime, and it will look almost similar on all those devices. But there is still some issue with this approach. This approach will only cover devices in this range. Suppose designer has created design for 640 to 960 bucket. It will scale down exactly same on 480 to 720 HDPI devices and 320 to 480 MDPI devices and so on. But device sizes in Android is not restricted to only these sizes. This is a range. So let's take an example of Samsung Galaxy Mega. It's an HDPI device. The density conversion factor is 1.5 and its actual resolution is 720 to 1280. So if we convert it into dB size, it comes into 480 into 853 dB. So if we compare it to the base size of Android device, which is 320 into 480, it's still 160 pixels wider and around 373 dB taller, which we can see as the yellow, light yellow color here. So designers should keep this in mind that in one density bucket, devices can range in at this size, and should keep design applications keeping in mind that the design should scale well on all these ranges of screen sizes.
Does the aspect ratio also change?
Yes. Aspect So now we will see few tips for designers how they can create designs for this variety of screens. First tip is designer should create base design of base size of MDPI device which is 320 to 480 multiplied by density conversion factor of highest supported density bucket. Why I am suggesting to create designs for highest supported density bucket because it's easy to downscale the assets for other density buckets. Now as designer has created base design, we just need to bother about the extra screen size available on different Android devices. For that consideration, we can divide the design elements into two parts. One is background element and another is foreground elements. Let's discuss about the background elements. So background elements could be color and it won't cause any problem because color will stretch automatically to accumulate extra screen size. Background would be gradient, it won't cause any issue. Background could be repeating patterns, similarly it will scale well. Background could be 9-patch drawable. So 9-patch drawable is an Android specific term. It's a specific drawable in which we can provide the stretchable area in both the directions, in x-axis and in y-axis, and we can left out few areas, few patches which won't scale when the drawable will be scaled. So in this image, we have marked this area and this area as stretchable, and we have left out the corners. So it will stretch like this for taller devices and for wider devices, and its corner will remain intact. So if our background is 9-patch drawables, they won't cause any issues because it will scale automatically. The last option for background is full screen images. We can use full screen images as backgrounds of our design. First of all, it's not recommended because if we use full screen images as background, it may consume a lot of memory at runtime. But even if designer wants to use full screen backgrounds,
so image size will vary depending upon HDPI or XXX DPI.
yeah, image size.
That means the load time will also vary.
So basically, if device manufacturers are putting extra pixels in display, they are also providing more processing powers. So as the aspect ratio, as we said that aspect ratio of Android devices can also vary. So if we provide full screen images as background, it will either stretch or skewed on different devices. There are few approaches using which we can avoid that. We will further discuss them in our further slides. So first approach is we can use image with largest supported dimension. Second approach is we can keep the image in the center and add a colored or gradient border around it, or we can stretch the image to accommodate the full screen. So the first approach, we can use image with largest supported dimension. So in this approach, suppose we are supporting the largest dimension of 1920 into say 1440 into 1920, then we can keep that image in that density bucket and can provide similar degraded images for other density buckets. Android will pick them accordingly, but there will be devices which are smaller than that particular size. On that particular devices, image will be cropped from the center. As an example, on Nexus 5, it's the full image will be displayed, but on Nexus S, image will be cropped from the center. Only the red border portion will get displayed on that device. So what designer should keep in mind? Designer should choose the images in a manner that no important information is lying around the corners because they might get cropped. In second approach, we can keep the image in center of the display and can add color or gradient border around it. So in this approach, I have added a brown color border which is visible on that image. The benefit of this approach is we won't lose any detail of the image, but the downside is the image or the background won't look perfect on wider devices or taller devices. The third approach is we can simply stretch the image to fill the entire screen. Here there are some square portions which get stretched in this image, which is not visible.
But if you look at, generally the websites like Facebook or Twitter, mobile apps, their icons are generally either top left or somewhere top right.
Right.
So I think that's like a pretty important information from that perspective.
So we are just talking about the background here, right? Not about the foreground elements. We will further discuss about foreground elements. So that's the next part of the talk. For foreground elements, we can categorize our content based on scrollability of the content into three parts. Either content would be non-scrollable, or content would be vertically scrollable, or content would be horizontally scrollable. So let's discuss about non-scrollable contents. If content is non-scrollable, content could either be in center, or in top left corner, or in top right corner, or like that. So if content is in center, like most of the splash screens of the applications, it will look fine on wider or taller devices. Content will still be in the center. But what designers should keep in mind, we developers can't change the size of the image for one density bucket. For other density buckets, it will be as big as their density conversion factors. So if these two are of same density bucket devices, image will be of same size. The rest of the space will be taken by the white space or by the margins. Or content would be aligned in top left corner, basically for left to right languages. In that case, the extra space will be taken by the right margin and the bottom margin. Or content would be top right aligned for right to left languages. But there will be few situations in which we want our content is non-scrollable, but we want to cover the entire screen of the device. Such one of the examples is this. So what things designers should keep in mind when designing such screens? Here are few tips. So designer can create designs in which some part is non-stretchable, like logo in the above image, and other parts are stretchable, like 5 list items in above example. But we developer can distribute the extra available space in certain ratio. So here we have distributed the extra space exactly equal in all these 5 text areas. It could be of certain there might be 2 elements which is taking the extra space and not rest of the items.
But they can't change the text size.
But for same density bucket, we can't change the text size and we can't change the size of the image. That will remain same. We can just accommodate the extra space in margins or paddings.
You cannot have a relationship between spacing and size of font?
For same density bucket, no, not easily. We need to do that programmatically, not by putting
Not by
the
the
constants in
not by the
there.
layout itself. So in iOS you can do that. In iOS you can actually have a relative sizing based on the space available.
You have only 3 or 4 sizes to cater to.
Yes. Now actually they've made one interface builder actually takes care of it. So you don't really need to go and make an iPad design or iPhone design. So all of it is in one. So if you think about it, there are a few devices which are of different sizes: iPad Mini, iPad Retina, iPad 2, and then the new iPhones 6, 6 Plus, 5S, 4, 4S. Size classes and auto layout constraints.
Another category of foreground content is the content is vertically scrollable. So if content is vertically scrollable, there is no need to handle extra available height on the device, because as our content is vertically scrollable, more content will be visible. We just need to cater the extra width available on the device. So list view is the major example for such content, and this is a complex list item. So here are few tips for designers what they should keep in mind. So they can keep left and right margins constant for all the devices for same density bucket. As we can see in this image, for both of the devices, left and right margins are equally same. To accommodate extra width in a list row, they can keep in this list example, I have divided a list item in 3 horizontal parts. One is the icon of the list item, second is the name of the list item and description, and a brief description of list item, and third would be a distance. So to accommodate extra width in list row, designer can keep left and right items with fixed width and can make items in center stretchable. If our designs are less complex and there is say only a list, only an icon for the list item and the name of the list item, then name will take the extra space. And same here, we can't change the size of the image, we can't change the font size of the text. Only the more text will be visible on wider devices. Here is another example. There would be a scroll view in which we can put these items. So this is an interesting example. We can put images edge to edge for all the devices. We can put buttons edge to edge, we can put edit text edge to edge. Few more tips. We can show the images which cover full width of device and can keep the aspect ratio intact. But yes, for this, developer need to put some extra effort and need to set the height of the image at runtime. But it's a very frequent thing, so everyone can do this easily. Designers can make text to cover full width, though we developer can't change the font size for same density bucket. On wider devices, extra content will be visible in one line. Designer can show buttons, edit text to cover full width, but only background will be stretched. Text on buttons, text on edit text will remain of same size, and for background there is a constraint that backgrounds can't be images, because in that case the aspect ratio will not be maintained. Backgrounds should be 9-patch drawables, gradients, colors, or rotating patterns for these elements. If content is not edge to edge, then content would be left aligned, right aligned, or horizontally centered. same constraints here. We can't change the sizes of the icons, sizes of the text. The extra available space will be accumulated with the margins. So suppose in this case if content is in center, then extra available space will be equally distributed into left and right margins of the device. These are basically the same tips. Can't change the size of the elements, can't change the spacing between elements. Only it means that if content is left justified, all extra will be covered by right free space. If right justified, then by left free space. And if content is in center, extra space will be equally distributed in left and right margins. So here is the last part of this talk, how we can accommodate content if it's horizontally scrollable.
Thank you.
The major example of horizontally scrollable content is view pager in Android. So view pager shows the pages, and we can swipe those pages horizontally. So in most of the cases, width of a single page is equal to the width of the screen. In that case, we can handle extra available space by above mentioned techniques. But in few cases, the width of page is not equal to the screen width. In that case, it could be possible that the content of left and right pages are peeking onto the same screen. It's an interesting case, and we can handle the extra available space in this case by using two approaches. The first approach is we can fix the width of peeking view and can distribute the extra available width in the margins. So here I am depicting the center page here, and these are the peeking views. On wider devices, there is more wide space available between the devices. In second approach, we can increase the width of the peeking views and can keep the margins between pages same. So these are the few tips.
This is for
landscape mode.
that will be a whole new piece to handle.
We don't support landscape mode. I have written a blog post for same content, and if you are interested, you can find it at winsource blog, winsor.com/blog.
Have you shared this thing with designers?
Yeah, we provide these guidelines to designers. I have just written a blog post, but before that, we share a doc with our designers.
Thank you.